Good morning, good afternoon, and good night. For our summative, we got a question where we have two lines, and the equations are given in parametric form. L1 equals x equals 3t plus 1, y equals 3, z equals negative 2 plus t, where t belongs to all real numbers. X equals 2s plus 3, y equals negative s plus 1, z equals 3s minus 2, where s belongs to the set of all real numbers. Now, this is what's given, and what's required is that we have to determine the points p and q if p is a point on L1 and q is a point on L2, such that PQ is perpendicular to both lines. So our first issue here is that we're given the equation in parametric form. So we're just gonna translate that over into a direction vector, as we have here, along with the points. And to do that, you just have to look at the coefficients: 3, 0, and negative 1. And you do the same for here: 2, negative 1, and 3. And in order for us to find PQ to be perpendicular, we know that the dot product of PQ and the points on the vector have to be equal to 0. And we repeat that again for both L1 and L2.
To continue on, we know that point P is 1 plus 3t, 3 and 2 minus t. The first value being the x dimension, y and z, and the same thing for q, 3 plus 2s, 1 minus s minus 2 plus 3s. But for us to find the vector PQ, what we need to do is subtract the point for q from the point of P. So what we do is we take the x value for q, which is 3 plus 2s, subtract it from P, which is done right here. Same thing for y, so 1 minus s subtracted from 3, and the same thing for the z value. Once we simplify that, we get the equation 2 plus 2s minus 3 for the x, minus 2 minus s for the y, minus 4 plus 3s plus t for the z dimension. Now going back to what Ahmed said earlier, what we need to do is find the dot product between PQ and point 1 and PQ and point 2. So that's done over here. So this is PQ, the vector, and the dot product, and PQ and the dot product between the second point. To continue on to the second page, what we do here is we go through the dot product, and the way that the dot product works is you multiply everything in the x by the x in the second bracket, everything in the y multiply that with the y in the second bracket, and so on and so forth with the z dimension. So once we do that for the first equation, the equation that we get, the resulting equation is 6 plus 6s minus 9t plus 4 minus 3s minus t equals 0. And that simplifies into 10 plus 3s minus 10t equals 0. And once, to go on with that.
So now, the rest of this problem is a piece of cake. We just have a linear system. So first we're gonna solve for t in our original dot product. So negative 2 plus 14 over 3s equals t. We're gonna sub that back into the simplified dot product, 10 plus 3s minus negative 10. Sub in this for t equals 0. And then we're gonna solve for s and t. So we have 90 over 131 equals s, 158 over 137 equals t. And now we're just gonna go back to our original equation and plug in our s value and our t value.
And now there's not a lot of math left, so what we do, we have our values for P and Q. P equals 90 over 131, and S equals 90 over 131, and T equals 158 over 131. So we take the equation, or the points for P, which is 1 plus 3t, 3, 2 minus t, and we plug in the value for T. So the value that we get for P is 1 plus 3 times 158 over 137, and the same thing continued over. For Q, the points that we have is 3 plus 2s, for x, 1 minus 5, 1 over s rather, and then minus 2 plus 3s. Again, we take the value that we found earlier for s, which is 90 over 131, plug it in, and we find the points. So this is point P over here, this is point Q, and these 2 points are what give us a perpendicular line to the set of 2 lines.
And that's how you solve this equation.
Thank you so much for listening. I hope you learned something today. Bye.